Have you ever really stopped to think about the magic that happens when you turn your car's steering wheel? I mean, it feels so simple, right? So direct. And yet you're effortlessly commanding this massive 2-ton machine. So let's pull back the curtain and uncover the brilliant engineering that actually makes it all possible. It all kicks off with this one simple action, a little turn of the wheel, a rotation that, every single one of us who drives is intimately familiar with. But this is just the very beginning of a really fascinating mechanical journey. And somehow, that simple rotation translates into the power to guide this entire vehicle, putting it precisely where you want it to go. The connection between that tiny little input from your hands and this massive output on the road, well, that's where the real genius is hiding. So, what is that connection? What's the mechanism hiding under the hood that translates your intention into the car's action? That's the big question, and that's exactly what we're going to break down right now. All right, so let's trace the path of that force step by step. We're going to follow it from your hands on the steering wheel all the way down to where the rubber meets the road, the tires on the asphalt. So, at its very core, a steering system really has one fundamental job. It's a translator. It's all about converting that spinning, rotational movement of the steering wheel into the side-to-side angular turn of the front wheels. Now, in most modern cars you'll see today, the real star of this mechanical show is a system called the rack and pinion. And trust me, it's elegant, it's super efficient, and you'll be surprised at how simple it actually is. Okay, and here it is in all its glory, with all the key players laid out. You've got the steering shaft coming down from the wheel. Then there's this little gear, that's called the pinion. It meshes with this long-toothed bar, which is the rack. And finally, you have these tie rods that connect the whole shebang out to the wheels. So, how does this whole thing actually work together? Well, it's a beautiful, pretty simple 4-step dance. Okay, so first, you turn the steering wheel. That spins the shaft connected to it and the little pinion gear at the very end. Simple enough. Second, as that pinion gear spins, its teeth grab onto the teeth on the rack. Third, this is the magic part. That spinning motion now pushes the rack either left or right. It's turned rotation into straight-line linear motion. And finally, the tie rods at each end of that rack just push or pull the wheels and boom, you're turning. It really is that straightforward. This quote from How Stuff Works just hits the nail on the head. The absolute crucial point, the whole secret sauce, is this conversion from a spinning motion to a straight line motion. That right there is the entire secret behind why this system is so darn effective. Okay, but there's another layer of magic happening here. It's not just about changing the direction of motion, it's also about leverage. I mean, why is it so easy to turn the wheels of a heavy car? The answer to that is hiding right there in the gears themselves. And this brings us to a really key concept called the steering ratio. It's actually a pretty simple comparison. All it means is, how far do you have to turn the steering wheel just to get the car's actual wheels to turn by a single degree? So for a typical passenger car, you're looking at a ratio of about 18-1. Now, what that actually means is you get this huge mechanical advantage. It's like a force multiplier for your arms. It makes steering feel easy. That tiny little pinion gear acting on the much larger rack is exactly what makes the whole thing feel so effortless. And of course, engineers play with this ratio for different kinds of vehicles. A sports car, for instance, might have a low ratio, like 12-1. That gives you that super quick, twitchy, responsive feel. But a huge, heavy truck, that's going to have a really high ratio. You have to turn the wheel a lot more, but it dramatically cuts down the physical effort you need to point those massive tires where you want them to go. Okay, so we've covered how we get the wheels to turn, but how they turn, the specific angles, well, that's a whole other piece of engineering elegance, and it's designed to solve a really subtle, hidden, geometric problem. Yeah, think about it for a second. When you make a turn, the inside wheel travels on a much, much tighter circle than the outside wheel, right? So if they both turned at the exact same angle, one of them would have to slip and scrubble along the pavement. That's not good for your tires or for control. So how do you solve that? Well, the answer is this really clever principle called Ackerman's steering geometry. Basically, the steering linkage is designed in such a way that the inside wheel automatically turns at a slightly sharper angle than the outside one. And what this does is it makes sure the paths of both wheels trace perfect circles around a single common center point. The result? A perfectly smooth turn with no tire scrubbing at all. All right, so let's bring all this engineering and geometry back to the most important person in the whole equation, you, the driver. Because a truly great steering system doesn't just turn the car, it actually talks to you. So why is the rack and pinion system so dominant? Why is it everywhere? Well, because it just ticks all the right boxes. It's incredibly accurate, it's super responsive, its design is simple and lightweight with very few moving parts, which means, less stuff to break and almost no energy is lost. But maybe its most celebrated quality of all is the road feedback. Because you have this direct, physical, metal-to-metal connection all the way from the tire up through the steering column right to your hands, you can literally feel the road. And this road feel isn't just a cool sensation, it's crucial information. It's telling you about the texture of the pavement, and this is the most important part, how much grip your tires have. It connects you, the driver, directly to the physics of what's happening. And this brings us to a final and kind of provocative thought. The future of cars is pointing towards steer-by-wire systems. That's where there's no physical link at all. It's all just sensors and motors. So as we move into that future, it really is worth asking, what do we gain with all this new technology and all these features? And what essential part of driving, that pure, beautiful mechanical connection to the road,